So I've been doing a lot of streaming on clean architecture in Next.js, and a lot of you have asked me to send you the GitHub repo link, which it wasn't open source, but I made a new one, and also to recap everything that we've learned. So this video is going to be that. We're going to recap everything that we learned about clean architecture and how to fit it into Next.js, and yeah, hope you enjoy. So clean architecture is a software architecture created by Uncle Bob or Robert Martin back in 2012, and it's basically a response or an attempt to integrate other previous architectures into a single actionable idea. And those architectures are hexagonal architecture by Alistair Cockburn, onion architecture, screaming, etc. So clean architecture basically tries to implement all of the ideas and aspects of these architectures into one single actionable idea. And Uncle Bob has drawn this diagram to help us understand how we can achieve this, right? So he uses layers, or clean architecture uses layers to structure specific code into different places in order to achieve the aspects. And let's actually talk about the aspects first. So the aspects of these articles is that they make our apps, or they make us code our apps independent of frameworks. So what does that mean? Your business logic, the core business logic of your application should not actually depend on frameworks. So I know this is a Next.js tutorial, and to be honest, this tutorial can be implemented in any of the JavaScript meta frameworks. But yeah, the idea is that we will develop our business logic, our core logic of the application, the functionality, in such a way that it doesn't depend on the framework. All right, so in this case, that is Next.js. The second one is that our application is testable, right? So if we code everything in one single file, presumably, it's not really testable, right? You have, you're mixing UI and database and all of these external factors, and that will prevent you from writing unit tests for your application. So clean architecture and all the other architectures that we mentioned above, they aim to make your app testable. It's also independent of UI. In the context of Next.js, that's exactly the same as independent of frameworks, right? Independent of database, regardless if you're implementing SQL Server or Mongo or CouchDB or Postgres SQL or Supabase or any other database tool out there, the business logic does not depend on it. And it achieves this through so-called repository pattern that we're going to take a look at it later. But basically the logic does not implement the database to save stuff. It just asks the repository to do that. And lastly, independent of any external agency. It just doesn't matter, right? The business rules or your application's features and functionality should not know anything about the outside world. That's basically what these architectures want us to achieve. And that's why it uses layers to separate specific type of codes in order to achieve this. So this is the original diagram that Uncle Bob drew. It's in the form of a dartboard or a bullseye diagram. And we can see the layers, right? The outermost, the blue one, is web, UI, external interfaces, DB, devices. Then we have controllers, presenters, and gateways. Then we have use cases, and then we have entities. And I'm gonna be honest, I didn't actually understand this diagram the first time. So I tried to redraw it, right? Here's the original one, redrawn by me, but I made a small change. I made this thick line that basically divides the outermost layer into two separate layers, where we have the infrastructure part right at the bottom, and also the API routes, web UI, external interfaces, anything that is consuming our application at the top. The rest is the same. And looking at this, I actually thought, let me take it even further and redraw it like this. And this made so much sense to me. So this is clean architecture, but through from a different perspective. So here's the frameworks and drivers layer, right? This layer, as I mentioned, is going to contain or keep all of the consumers of our system, right? And that is the API handler, that can be a Node.js server as well, or a server component, or server actions, or AWS Lambdas, or even Stripe webhooks, etc. Anything that has a touch point to our core logic, our application's core logic, right? And then we have the interface adapters, the controllers and presenters. That's how that layer is named. Then we have the application layer, or the use cases layer right here, which will also hold the infrastructure interfaces, and we'll talk about that. We'll have at the bottom, we have the entities, which are the models, right? The link, collection, relation, user, to do, list, whatever your application is building. Errors, because we want to have custom errors, and we'll talk about that as well, etc. And then we also have the infrastructure layer at the top. And in the infrastructure layer, we want to isolate repositories and services. Why? Because they always rely on some frameworks and tools. Like, for example, repositories rely on specific databases, right? We might be using Postgres, or there might be a Redis database, etc. So because we don't want our core logic to depend on those technologies, we need to isolate all of that functionality into its own layer and use them or consume those repositories and services through DI. Because if we consume them directly, the dependency is going to be like this. That means the application layer depends on the infrastructure, and we don't want that. We want this arrow to face the other way, so that the infrastructure depends on the application, but the application uses things from the infrastructure through DI. We'll get into more detail. But as you see, and you might have noticed it by now, clean architecture describes a dependency hierarchy. It's basically telling you how to structure your code in such a way that the dependencies do not fall on either frameworks or infrastructure stuff like databases, services, email clients, etc. So to demo clean architecture in Next.js, I actually built a new, smaller Next.js application. It's basically a to-do application that implements authentication. There's a sign up, there's sign in. Let me log in. And yeah, we have to-dos, explain clean architecture, make UI more responsive. And that's a to-do because, as you can see, there is a bit of lag. But we don't really care about the UI in this project. So I'm going to post a link to the deployed version and also to the GitHub. But yeah, this is the app. Let's get into it. Okay, there's our project, and let me hide the camera for a little bit. This is the project. Inside of the app directory, we keep everything Next.js related, right? These are the authentication screens, some UI components right here. This is ShadCN, other components, pages, layouts, and also actions. So app is everything Next.js related. That means it's everything frameworks and drivers, right? This is app. Then we have the DI folder, which is everything dependency injection. We're going to talk about that later. We have Drizzle, where we set up the Drizzle configuration. We have source, which keeps our actual application, the core application here. And the folders represent the layers. So for example, here's the application layer, and inside we have the repositories, services, and use cases. So application layer is this one, and it held the use cases and also the infrastructure interfaces. And those are the repositories and services. So if you see, we have TypeScript files, todos.repository.interface.ts. This basically holds the interface for the repository, and it tells the actual implementation which methods we wanted to implement. Okay, then we have the entities layer right here, and we have the errors and models. Again, entities is at the bottom right here, models and errors. And here's the, for example, to-do model. I'm using Zod because models, by definition, also handle validation. So if this wasn't JavaScript, we would have needed to create classes. But because this is JavaScript, we can get away with just using a ZOD schema and then export the type based on the schema. And that is enough in our case. We're going to explain every layer in more detail as we go through a specific operation like create to do. But so far, yeah, we have entities, infrastructure is here, and these are the implementations of the interfaces that we saw here, of these interfaces. We have their implementations here. For example, we export a class that pulls in the interface from the application layer and then just implements it. Cool. There's also a mock version of the same repository. It basically uses in-memory. We'll talk about this when we get to testing. And that was the infrastructure layer. And then we have the interface adapters, which is just controllers. So for example, controllers are like create to do controller, get to do's, toggle to do controller, etc. That's the source directory. And then we have the tests, which just basically holds the tests. Inside of the unit folder, I am mirroring the exact folder structure as I have it in the source directory. So here's application and interface adapters. I only have tests for these two layers because that's basically the core logic of my application. Okay, so that's the folder structure. Let's now go and see how the operation flows when we try to create a to-do. So here's how the UI looked like. We just have an input and a button. Hello world, we press that button and we trigger the create to do operation flow. There we go. So starting from the app inside of the actions.ts, again, this is the frameworks and drivers layer, the outermost, the first layer right here. And this is the touch point where we trigger the create to do flow, right? Server actions. There's a server action called create to do. And I'm using Sentry with server action instrumentation is a function from Sentry that allows me to instrument my server actions. And I'm going to show you all about it later. But the server action basically gets the data from the form data, from the arguments here, gets the session ID from the cookies, and then it just awaits, invokes the create to do controller, and it passes on the data and session ID. That's basically it. It implements a try catch because every layer can throw an error, a custom error, and those are these errors. And because we are in the frameworks layer, we want to handle these errors and return a UI friendly message or do something so that the UI reacts accordingly. The core application logic is not aware of any UI. That's why it implements custom errors so that the consumer of the application, in this case that's the server action, can handle these errors as it needs. Okay, so there's a try catch. We invoke the controller in the server action. We handle the errors accordingly. For example, if it's an input parse error, we just return the message. I'll talk about that as well. Unauthenticated error, you must be logged in to create a to-do, fine. Otherwise, we capture the exception and we send it to Sentry. Capture exception actually comes from the Sentry package. And then we return an error. An error happened while creating a to-do. The developers have been notified. Please try again later. Right? Simple. If no errors happen, we revalidate the homepage, the slash, and we just return success true. That's basically what happens in this layer once we click that plus button. And let's get into the controller now. Here's the create to do controller. We get inside, we get the input and session ID. I have a start span wrapper, which basically creates a span in the trace so that I can later go into Sentry and see all of the operations and how long or how much time they took. I'm going to show you this later, but for now, here's the controller. I'm checking for a session ID. Controllers is the first touch point in the core application or core logic, right? And they have a responsibility to check for authentication and also for input validation. If we want to create a to-do, we must provide the name for the to-do, right? We cannot just say, here's an empty string and create a to-do with an empty string. That's not accepted, right? We can just say undefined. That's also not accepted. So it has to be a string and it has to have some length. And we also need to be logged in to create a to-do, because if we're not logged in, we can't really create a to-do. Only logged in users can create to-dos, right? So the controller right here is where that logic happens, where that input validation and also authentication checks happen, because this is the first touch point of the system. This is where all sorts of frameworks and clients are going to be using our system. And because we are designing our application in such a way that we don't care about the UI or the framework, that's why we do the check a layer into the core logic and not over here, because we want that logic to be part of our core application, not do the authentication check in the server action. No. So that is the reason why we're checking on the session ID here. If session ID does not exist or it's not passed, we just throw an unauthenticated error, which comes from the models or entities layer at the bottom. Here's the unauthenticated error, and this is how all of the errors look like. Let me actually zoom in. There we go. So it's just an error that extends error. It accepts a message and optional options, and then it calls the super constructor for the error class. That's all. And as you can see, I have authentication error, unauthenticated error, and also unauthorized error. Okay, if no session ID exists, throw unauthenticated error. So whoever invokes this controller will handle that case as they need. Then we use the getInjection function to obtain the authentication service. This is the DI part, but we're going to talk about that later. Right now, it's important to know that when we use the getInjection function, it will return us an instance of the I authentication service. I stands for interface. And if you remember, services and repositories had interfaces in the applications layer and their implementations in the infrastructure layer. While we are here, we're not going to be working with the implementations, but we're going to be working with the interfaces so that we don't rely or don't pull in database stuff or any third-party services stuff. So the authentication service is of the type of the interface. That means we can do create session or invalidate session or generate user ID or validate session. This is basically what the authentication service is capable of, and we can invoke the validate session method. Here, we pass in the session ID, which we have validated that it exists, and then we wait for the user. Additionally, validate session will throw an error. It will throw an unauthenticated error if the session ID is invalid or if the user doesn't exist, etc. So at this line right here, we know that the user is logged in and it's an existing user and there is no issue regarding authentication. That's why we go use the input schema, which is defined at the top of the file. It's a Zod schema that defines a to-do property that's a string with at least one character. And if, for example, Zod cannot parse the input, it will return us an input parse error. And if that one exists, we'll just throw an input parse error, which again, it's our error. It's an error that we have defined right here. In this case, the consumer sends us an input that doesn't really adhere to the schema that we have defined. We don't accept zero length to-dos. So we're going to throw an input parse error, invalid data, and then we'll pass the cause here. That's it. If there are no errors, at this point, we know that the user exists, the user is signed in, and also the data is valid. And that means we can start using use cases to fulfill that operation or to execute the operation, right? Which is the operation of create to do. The reason why we have controllers and not use the use cases directly is because some operations can be a bit more complex. In this case, we can only see one use case, and you might think, let's just use the use case directly, but that's a big no-no. In some cases, the operations will need multiple use cases. And this can be one as well. For example, we have a create to do. In my application, I don't have lists, but imagine if I had lists. I would need to create the to do first, And then if a list exists, I would need to find the list and add it to the list. Or if the list doesn't exist, I need to create the list and add it to that one, right? So we have more operations or more individual operations. Use cases are exactly that. They are individual operations that accept pre-validated data and do only one thing. They implement separation of concerns. Create to-do use case only creates a to-do. It doesn't add it to a list. It doesn't delete it. It doesn't update it. It doesn't publish it. No, it just creates a to-do. Adding a to-do to a list is a different operation, and therefore we need a different use case. So as you can see, we need a way where we can orchestrate these use cases, and that's why we have controllers. That's why we can't really use use cases directly into our applications, because the logic or the order of the use cases is part of our core logic. That's why we need to keep it inside here instead of pushing it outside. That's crucial. So we invoke the create to do use case right here. We get the to do, and then before returning it, we actually pass it through the presenter, and then we'll return whatever the presenter returns. The presenter is defined at the top. It's just a simple function that takes in the to-do of the type to-do model that we have from the models, from the entities layer, and we return a plain JavaScript object that maps out the properties. You might think this is an overkill, but check this out. The reason why we have presenters is that we want the data coming outside of our core logic, which is this, to be UI friendly. We don't want to leak out models outside. Anything that's returned from the controllers will be just plain objects and will be UI friendly. For example, in this case, I'm just mapping out all of the properties one by one, and there are no other properties on the to-do model that I'm avoiding. But if this was a user, the user model would most likely contain a hashed password field. I would not return that. We don't need the actual hashed passwords returned from the backend to the client, right? That's dangerous. We don't want that, and therefore the presenter will take care of that. The presenter will return a subset of the properties of the model that should be sent to the client or to the browser or to whoever consumes the application. And that is for the security reason, or the security reason behind presenters. But there's another one. Let's say we have date of creation in the to-do, right? We want to keep track when we created that to-do. So when we actually complete it, we want to measure how long it took us to perform that task or to close that task, to close the to-do. In that case, we would save the to-do in the database as a date with a time, right? A timestamp. We would treat it as a date in our application, as in JavaScript date, and we can return it as a date and then format it on the front end or in the browser. But that means we also need to ship a date library like datefns or moment.js in order to do that on the browser. We don't need to do that on the browser. We can actually do it here. We can import that library and convert that date into the format that we want without necessarily shipping datefns or moment.js or whatever we use to the browser, so that when the browser receives the results through the response, the date will be a string. It will not be an actual date object. And that's another reason why we need presenters, or why presenters are good, because of performance reasons. So we get to keep any sensitive information from spilling outside of the backend, and we can also avoid shipping some libraries in order to format the data or the result in a specific way. We can do that here in the presenter. Okay, so that's the controller, right? Let's get into the use case. So create to do use case. Now we are in the application layer. The create to do use case accepts an input that contains the to do. It's a string. It's not undefined because it has already been validated. And it also contains a user ID that knows that the user is valid and it exists, and it is the user that is asking to create the to-do, right? So the use case does not check for those things, but the use case checks for authorization. It knows the user, but what if there are different types of users, right? What if, for example, free users are allowed to only 5 to-dos for some reason? If that's the case, we can throw an unauthorized error from the use case. That's because use cases by nature, they are individual operations. And individual operations can or cannot be performed by every user. As a type of user, which is free or admin or tier 1, tier 2, tier 3, etc., based on the type, we would either allow that user to perform this operation that the use case describes, or throw an unauthorized error and let either the controller or the framework handle it. So I don't have it here, but this is where you would do that check. Authentication stays in the controller, but authorization is in the use case. Over here, we're still using the get injection function to get a hold of the to-dos repository. We know that the input is validated. We know that the user exists. We know that the user is authorized because there are no authorization checks. So we just invoke the create to-do method of the to-dos repository. We pass in the data. We get a to-do back, which is of this type, and then we just return it. Okay, that's all that the create to do use case does. Okay, aside from being wrapped with a start span, so we can see how long creating a to do actually is when we open Sentry. More like how costly this function is. Okay, and then we just return it and that's it. Use cases are a lot simpler because they only do one thing and one thing only. Okay, we're not going to go into the entities because, models and errors, we've already covered them, but let's get into the infrastructure layer now. So as I mentioned, we're using the interfaces in our core application logic, but through the get injection method, we actually get or interface with the implementations. So if I go to the implementations of the to-dos repository, we can see the actual repository that implements the interface, but it actually uses Drizzle to communicate with the database. Okay, so here's the to-dos repository. Here's the create to-do method. It takes in to-do insert type, which is user ID, to-do, and completed. Again, I have a start span to measure the costs of this function or to measure how long it takes for Drizzle to put this type of data in the database. I have a try catch block. I construct my query db.insert into the to-dos table. Here are the values, and then return the new to-do back. There's the query. Again, I do a start span with the db query operation here so that I can check it out later in Sentry, but this is how we trigger the query, query.execute. We get back the created, the newly created to-do, and we do some checks. If it exists, we return it. If not, we throw a database operation error, cannot create to do. Because query.execute returns an array and we destructure it like so, it might not exist. So we throw database operation here, but we also have a catch block to catch any stray errors as well. In this case, we want to capture those exceptions and send them to Sentry. We pass the data of the actual to-do that cannot be created. And I don't have it here, but this is the moment where we need to convert those database specific errors into our entities errors, into basically database operation errors. Depending on what database you're using, it can throw different types of errors. For example, there is a lot of difference between the errors thrown from Drizzle and Supabase. So read the docs of the database, see what it throws, and figure out how to map those types of errors into your entities errors, right? Because we don't want to rethrow database specific errors, because if we want to handle them, that means we need to import them. We don't want to import database specific stuff outside of the infrastructure layer. That's why we need to convert all of the exceptions or errors that are being thrown from the infrastructure layer into entities errors. Okay, and that's basically the function create to do that creates a to do and puts it into the database. As you can see, we don't do any checks here. We don't do input validation because that's already been done. We don't do authorization or authentication because again, that's already being done. Repositories take in data, they don't ask questions, they put it into the database and then they return it. That's all. This is like a thin layer that needs to exist in order to separate database related stuff, or for example, for services, any frameworks and SDKs from the rest of our application. So that when we want to test our application, we don't actually need to have a database running in order for our tests to execute. And for example, here's how the authentication service looks like. Again, same thing, it's a class that implements an interface. I'm using Lucia for authentication. In the constructor, I'm setting up Lucia, and here's the validate session, which basically calls the validate session method of Lucia. If there's no user, throws the unauthenticated error. Otherwise, it uses the user's repository to get the user, does a check again. If everything's well, it returns the user and the session. That's how I validate the user's session in my application. So it's not a database, but it's still a third-party dependency. It is a library for authentication that we don't want to be weaved into the core logic of our application. And that's why we separate it into its own service. Simple. Okay, let's talk about this red line right here and how we achieve this. We saw how the direction of the arrow is achieved, right? Infrastructure depends on the application. Why? Because here we are in the service, which is infrastructure. It implements the interface, which comes from the application layer. As you can see, these are the .interface files that I showed you earlier. So this is how the infrastructure depends on the application. But back in the application layer, we use the get injection function to obtain the repository or the service and invoke its methods. Everything DI related is being kept in the DI folder. So DI, and then we have the container.ts. This file creates the dependency injection container. It initializes all of the modules, for example, the to-dos, users, and authentication modules. I also have a destroy container, which I use in unit tests. It calls the initialize container automatically if we're not in testing environment. And it exports a get injection function that takes in a symbol, takes in a string, and it returns the registered service or repository with that string. There's some TypeScript gymnastics in order to achieve type safety. Feel free to copy this in your own project. To keep this video shorter, I'm not going to explain what K stands for and the DI symbols and the DI return types. Check out the GitHub repository and you'll see how everything is connected. But basically, get injection returns the service or repository that's registered by that name. For example, registered as iAuthentication service. And how does it know which one is it? Well, the application container.load is what tells it to. So let's go into the authentication module. There we go. The authentication module is a new container module that initializes everything related to authentication. And in our case, it's simple. It's just an authentication service. So as you can see here, we are branching based on the node environment. If we are in testing, we're going to register something. But if we're not in testing, we're going to register something else. Let's start with the something else. We use the bind function that we get from the arguments to register the authentication service, the actual implementation of the authentication service with the interface. And we pass in the symbol as an identifier. But if we're running tests, we're going to get the mocked authentication or the mocked version of the service. So this is how we can write unit tests without having real databases or real services. Same goes for the to-dos module, but it's just going to be the repository. There is a catch though, because we're using Inversify for our dependency injection container. In Next.js, we cannot use the Edge runtime, we have to use the Node runtime. That's because Inversify uses reflection, and the Edge runtime does not implement the reflection API. That means if we have a middleware in our application, it's just not going to work. In order to set up Inversify, I do have a specific video on how to set up and install Inversify in Next.js. So I'm going to drop a link of that video if you want to see how I have this set up. But basically that is exactly how, using DI, we can hide or abstract away specific implementations of databases and services behind interfaces. And those interfaces can live in the application layer. Okay, that's all the layers. Let's actually check out the tests now. So in our tests folder, in the unit, we have application and interface adapters. Let's start with the application tests. So here's the create_to_do.usecase.test.ts file. This is the unit test for the create_to_do use case. And at the top, we import reflect metadata. We have to because Inversify. Again, check the video in the comments below. We import the after each, before each, expect and it from vtest because we're using vtests for our tests. We bring in the destroy container and initialize container from our di/container.ts file to set it up before and after each of the test cases. And then we have the test case itself. Here's a great guide on test names. It is a short 3-minute video by Artem that tells you how you can name your test cases better. Do check it out, it's really cool. Okay, so it creates to do. This is the test case that tests whether the use case creates the to do correctly or not. So first, we await the sign-in use case. So we can sign in. We do need to have a valid session if we want to create a to-do. And this user is already defined in the mocked version of the authentication service. So we don't need to register in our unit tests. And then we just expect the create to-do use case. We pass in the to-do with valid input. Remember, this is the use case, not the controller. The controller checks for errors thrown because of unauthenticated or input parse error, etc. This is the use case. The use case must accept pre-validated input. So we pass in valid input, we pass in a valid user ID, and then we expect the promise to resolve and to return an object that matches this. We have write unit tests for our to-do. We have user ID set to 1 because that is the this user's user ID. And we have completed set to false because by default, new to-dos must not be completed. And that is the only test that we have for the use case. And if I want to run it, I can just run it and see that green check mark because it's true. If I change this user ID to 2, that's going to be wrong because the username 1 has a user ID of 1 and not 2. So if I run it now, we're going to see an error. Expected a type of result to match a different type of result. And we can see the output better. We're going to see, okay, we expected a user ID of 2, but we actually received a user ID of 1. And that's how we know that our unit tests actually work. So there we go. That is the use case test, right? It only tests whether it works or not. If we go into the create to do controller tests, we're going to see more tests. First, at the top, we do the same. For every test, we bring in the reflect metadata, and after each, before each, and then we do initialize container, etc. But then, here's the create to do test case. In this time, we're testing the controller instead of the use case. We pass in valid data and a session, and we expect to return a valid object, right? And this works. There we go. But aside from that, we have a test that expects it to throw for invalid input. So we sign in and then we invoke the controller without a to-do. With a plain object, we pass in the session, and this scenario should result in an input parse error. We have to make sure that errors are being thrown and cover them with unit tests, because that's how we can make sure that we are providing an API so that whoever consumes our logic can handle or can receive the correct errors so it can handle them. So in this scenario where to-do is undefined, we expect an input parse error. If the to-do is defined but it's 0 length, we also expect an input parse error. So if I run this test, there we go, right? It's correct. I also have a test that expects the controller to throw an error if we're unauthenticated, right? So we are invoking the to-do controller. The to-do doesn't matter in this case because we're sending undefined for the session. And we expect it to reject with the unauthenticated error exception. And if I run this one, again, we can see that invoking the controller without a session will result with an unauthenticated error. And that's how I can check for all of the different scenarios that a consumer can use the controllers. I have unit tests for all of the controllers, and they have multiple test cases. So if I run all of them, I don't need to have a database or anything. I can just run them and sleep well at night because I know that my controllers and use cases function and behave the way that I want them to. And I'm actually using this in my GitHub pipeline. So if I go to GitHub test.yaml, we're going to see that I have a test workflow that gets triggered on every push. It has a test job. It checks out the repo, sets up node, installs all the dependencies, and it runs the tests with coverage because I want to report that coverage or upload that coverage to Codecov later. And this is how that looks like. If I do npm run coverage, all the tests are going to be invoked, and this coverage report will be generated as a file. And that's basically how clean architecture can help us structure our code in a way that it's very easy to test, as you can see. So we don't have excuses not to write tests anymore, right? Okay, while we are on the topic of code coverage and Codecov and Sentry, let me tell you about Sentry. So full disclosure, I do work at Sentry. I'm a developer advocate at Sentry. So of course I'm going to be biased. But if you don't know what Sentry is an application performance and error monitoring platform that supports pretty much all frameworks and languages out there. It is source available, which means you can also deploy it on your own infrastructure, on your own server, and use it for free. I'm going to go back to that place, the create to do controller. There we go. This is our controller. And I'm going to talk about this piece of code right here. If you want to see how Sentry is installed in Next.js, check out the docs. There's also a whole bunch of videos on Sentry's YouTube channel, but it's really simple. So I have Sentry set up here, and I'm using the start span to wrap the whole container, and then inside of the validate session, I have a nested span that wraps the validate session in a span of its own. So I'm using this start span across the whole app, right? And what this does is it creates a span that tells me when a certain function gets executed and when it ends. So I know how long it took for that function to finish. All of that is being sent to my Sentry account. So here's a Sentry dashboard. In the performance tab right here, I can scroll down and check out the server action / create to do action. This is the reason why in the app actions, I have the with server action instrumentation function and have the whole server action wrapped because I want to instrument the server action. And this is what I get. So when I click into it and go to the sampled events, I'm going to get real events that were triggered on the production environment on Invercell and were triggered by real users. I don't keep track of the users, but it is possible because we have authentication in our application. We can track the users as they trigger the server actions. But looking at the duration, we can see how long each of them took. Here's one that's a bit longer than the rest. It took 556 milliseconds. So let's check that one out. When we click into it, we get the trace view. And the trace view will lay down all of the spans that we have created in our application with their timings. So let me make some more room and I'll show you the trace. There we go. So here's the trace hierarchy. We start with the server action / toggle to do. We invoke the toggle to do controller. We use the get injection method to obtain the authentication service instance. And then we trigger the validate session. Inside, Lucia takes over and it makes 2 post requests to Terso because my Drizzle configuration uses Terso as a database. So as you can see on the left side, we have a hierarchy of our code base. If you go in step by step, you'll see everything that gets executed when we click to toggle a to-do. So if you're a new person joining a project, just by looking at the trace, you can actually see how the operation flows. So even if you're not familiar with the code base, this will give you a really good picture and it will help you with onboarding. But yeah, that's on the left side. On the right side, we have a visual representation of those spans, and let me actually hide my camera, of those spans and their timings. So I'm gonna make a split screen right here. The main server action toggle to do took 556 milliseconds. Out of those 556, 536 were spent inside of the toggle to do controller. And it does make sense because the action does not actually do anything more than invoking the controller and then handling the results. Now let's dive into the controller. First, we do the get injection, which takes 0.7 milliseconds. This is in production on Vercel. So you can see that dependency injection isn't really an expensive operation. It's actually practically free. And then after we have the injection, we get into the authentication service and we invoke the validate session. And I'm going to toggle these now. Inside of the controller, we have these 4 steps. The majority of the time is spent where? Here in the validate session. So if you know that the toggle to do is super slow, you'll know where to look at. If you were to optimize the performance of toggle to do, you would need to look into the validate session functionality. Not necessarily in the toggle to do use case because it's not really a significant time. The majority of the time is spent here. So if we toggle that and get inside, we'll see 2 functionalities. Validate session, which is being done by Lucia, and then we use the user's repository to get the user after we validate the session to check if the user is existing or not, right? Again, if you want to optimize this, this is where the majority of time is spent, not in the user's repository. Can you do something about this? Maybe, maybe not, but you know where the majority of the time is spent. And then you can see how Drizzle uses the Terso adapter to send post requests to Terso. And these 2 are what makes the validate session take 336 milliseconds. We can't really optimize this. And this is the trace view. There's a whole bunch of modules like requests. The requests module will give you all of the HTTP requests that your application is creating, the percentage of 300s or 400s or 500s, so you can see which endpoint or which requests errors out most frequently. There's also assets, which is a list of JavaScript files and icons and images that your application loads, and you get to see what is the average duration of that as well. You can see the favicon. In my case, it's on average 1.1 second. Maybe I want to optimize that. But this tells me that it's taking pretty long on average. So I'm going to look at this in my next sprint. We also have something like Web Vitals that the client SDK measures for us. And we're not talking about Lighthouse Web Vitals. We're actually talking about real user production, real world Web Vitals. And they don't look good in my case. You can see that the score is poor. The sign-in page is pretty bad. The time to first byte is almost 3 seconds. I can get in. I can see all the individual page loads. Here's a slow one. And this will take me to the trace view again. But this time I get to debug how the page load happened. And why was it slow? Well, this is the biggest chunk here, the redirect. Everything else seems to be reasonable except the redirect. Is this something I can fix? Maybe, but I know that it's the redirect that's making this page load more than 3 seconds. All right, let's check out the errors now. In the Issues tab, we can see a list of all the errors that our application reported. And if you remember, we had the capture exception sprinkled around the code that sends an exception to Sentry whenever it happens. And here's one. There's an error inside of the sign up server action. The message is username taken. If we click into it, we get to see that it happened 5 times. It affected 0 users because I'm not tracking the users, but you get to see how many users are also affected by this error. You get to see in the last 24 hours how many times the error happened, and you get to see the stack trace. So the stack trace helps you see where the actual error happened, and you can even click into the GitHub link and it'll take you to the exact line of code where the error happens. And you also have all sorts of other information, for example, info on the operating system, the runtime, the cloud resource, etc. Even the device. Even though this is a server, it gives you information on the actual server, which is pretty cool. So one thing you can notice here is that these green lines, and if you hover on them, it says covered. This is basically the test coverage that I generate and upload to Codecov. And because Sentry integrates with Codecov, we can click on this little umbrella, the Codecov logo here, and it'll take us to the Codecov dashboard, to this line again, but we can see in our whole project, in our whole Next.js clean architecture project, that we actually have 100% test coverage. This is what I'm talking about when I say clean architecture makes it so easy for us to write unit tests. You can see that I have 100% test coverage. I know it's not a big app, but I also didn't break a sweat achieving 100%. So that's basically Codecov, and that's how it integrates into Sentry to tell you if this error has been covered by a unit test or not. So yeah, that's basically clean architecture in Next.js. I'm going to drop links to the GitHub repo, to the original post, to the diagram, to everything mentioned in the comments below. So make sure you check out the pinned comment at the top of the list. If you like this video, of course, it goes without saying, but I'm going to say it anyways. Hit like, subscribe. Let me know if you want to see more like this so I can spend my time creating more content like this. And yeah, share it with your friends. I think clean architecture in Next.js is a pretty cool thing. It's not super hard, even though it might sound a bit intimidating, you know, like architecture and stuff. No, it's actually really simple and it gives you a lot of benefits. So yeah, here's how you can reap all those benefits. I hope you enjoyed watching this, and yeah, I'm gonna see you in the next one. Take care.